This is a great little revision question from GRE Subject Maths 2023 practice book, question 33. Okay, so we have a spherical tank of radius 5 metres and it contains water that's draining out. Let's just have a quick look. I've tried to do a little bit of a diagram here. Okay, so we have the spherical tank which is radius 5 metres and the water is draining out at the rate dh dt, and we know that the depth, which I've called h, is decreasing by 1/3 of a metre per second. So we know that dh dt is minus 1/3, and what they're asking here is that the maximum depth of the water in the tank is 2 metres at the time. So we know that h is 2 metres. What is the rate of decrease of the volume of the water in cubic metres per second at that instant? Now there's two problems here. The first problem is answering the question, but the second one is what on earth is the formula for the volume of a spherical cap? I certainly don't remember it. If you do, great. Well, this question you can move straight on to the second bit, but if you don't remember what the formula for the volume of a spherical cap is, then you have to derive it. So what we're going to do there is we're going to use volumes of revolution, and the easiest way to do that is let's just draw ourselves a nice circle. I'm probably not going to do this very well. Here's a circle here. Oh, that's not too bad. Good. Okay, and basically we're going to flip this on its side. That's the easiest way of doing it. This point here is R. We're going to find the general formula for the volume of a spherical cap first, and this point here, which is basically here, this bit is H. So this point here is R minus H, and this is the depth of the water. And what we're going to do is we are going to rotate this around the x-axis, and then we're going to sum up all of the little discs, and so the volume of the spherical cap is going to be equal to the integral between r minus h and h of pi times y squared, and this equation obviously is a circle. X squared add y squared equals r squared, and so therefore y squared is r squared minus x squared, and so that becomes the integral between r minus h and r of pi times r squared minus x squared dx. Okay, so in order to do this question we need to solve this integral, so let's get on and do that. The integral itself isn't particularly hard, so that equals pi, take the pi out, r squared x minus x cubed over 3 between r minus h and h, and that equals pi times r cubed, putting the r in first, minus r cubed over 3 minus, we just have to be careful with our minus signs here, r squared r minus h minus r minus h cubed over 3. So we've just got to be careful expanding all of this out with our minus signs. I'm not going to bother collecting these terms up, and you'll see why, because they all cancel. So that's r cubed minus r cubed over 3 minus, and let's keep this in a bracket here, r cubed minus r squared h minus, and now what we've got to do is expand this, r cubed over 3 minus 3 r squared h over 3, add 3 r h squared over 3, whoops, sorry, I've put the brackets to minus h cubed over 3, and this one you can simply do just by Pascal's triangle, so that's quite good. And now we find that, let's just sort out these negatives, r cubed minus r cubed over 3 minus r cubed, add r squared h, add r cubed over 3 minus r squared h, add r h squared minus h cubed over 3, and almost all of this now cancels, which is why I didn't bother collecting them in the first place, and that equals pi r h squared minus h cubed over 3, which equals, in a more formal way, pi over 3 h squared, taking the h squared out, 3r minus h, and that is the formula for the volume of a spherical cap. Okay, but we'll leave it in this form, and you'll see why, because basically now that we have the volume, and if we go right back to the beginning of the question here, we know that the radius r is 5 metres, is 5 metres, and we know that the depth of the tank is 2 metres, so we know that h is 2 metres. So in actual fact, we can clarify this and simplify it a little bit. So that equals the volume of the cap in the question, or the volume of the water. The volume of the water, we might as well keep it to the question, is equal to pi times 5h squared minus h cubed over 3. Now, even though we know that h is 2, first of all, we've got to find the rate of change. And to do that, we can't put h equals 2 in yet. So what we have to do now is we have to find the differential of the volume with respect to time. And remember, let's just go back to the question. That is what we're trying to find here. The rate of decrease of the volume of water at the time when h equals 2. So we have the rate of decrease of the volume with respect to time is equal to pi. And this is why I didn't change the thing from here to here, basically differentiating with respect to t. Well, first of all, we have to use implicit differentiation, differentiate with respect to h first, so that equals 10h, then times dh dt by implicit differentiation, minus 3h squared cubed over 3 times dh dt. Right, now we don't need to simplify that. All we need to realise is that the question asks us, when h equals 2, what is dv dt? Now, we know that when h equals 2, dh dt, it tells us, is minus a third. So all we need to do now is just stick in these values. Let's try and keep it on the same page. So dv dt at this time is equal to pi times 10 times 2 times minus a third minus 3 times 4 over 3 times minus a third. And it's as simple as that, which basically equals pi minus 20 over 3 add 4 over 3, which equals minus 16 pi over 3. That is the rate of increase. So the rate of decrease is simply get rid of the minus, and so the rate of decrease is 16 pi over 3, which is answer A. So this is great practice, not only in finding the rate of change and solving that, but also in using volume of integration to find a volume. Now, whether or not you could do that in 2 minutes is another question, and that's all you tend to get on these GRE questions. But either way, it's fantastic revision. Well, I hope you found this useful. If you have, please press the little thumbs up button and subscribe to the GRE Academy YouTube channel.